Welcome to physics class. I'm a tutor Black Adam. So that circuit there is the circuit, and then that's the battery, and then the battery has negligible resistance. So equivalence resistance means that you need to find total resistance. So we have total resistance, which is resistors parallel plus resistors in series, or plus other resistors. So that would be sum over product, or that's product over sum. So for parallel plus the resisting parallel, which is 2 ohm, and then it's 3 times 6 plus 3 plus 6, so 3 plus 2, so 3 times 6. So resistance total will be 3 times 6 is 18, and 3 plus 6 is 9, and then plus 2. So 18 divided by 9 is 2 plus 2. So resistor total will be 4. That is 2 plus 2, so it's 4. The unit for resistor is ohm, and then that is it. So let's say current through 2 resistors. So that's 2 resistors, that's all the current that flows in the circuit. So that means that we have the total voltmeter, total voltage, and then we need to have the total resistance as well, and then calculate the current. Then we follow Ohm's law, which says current total will be potential difference total divided by resistor total. So potential difference, total potential difference is 6 voltage and 6 volts, and then the ohm is 4 ohm for the total resistance. So 6 divided by 4 is 1.5 ampere, and that's the current that flows there, 1.5. And then the other thing that we have, we're done. That's for the question. So we go to the next question. They say the current through resistance 3. So remember, 3 is in parallel with 6 ohm. So we need to find the ratio. So the ratio there will mean, so we need to get the ratio. So the ratio will be, remember, we need to know how much is going into each. So it's 3 to 6, so the ratio is 1 to 2. So the total 1 plus 2, the total ratio is 3. So what we do, we're going to say 2 over 3. Okay, so 2 over 3 will go through there, and then 1 over 3 will go through the other side. Remember that less resistance, more current, more resistance, less current. And then 2 over 3 multiplied by 1.5 ampere, that gives us 1, and then 1 ampere. Another thing that we do, we say that potential difference on the 6 ohm. So what we do, we need to look at the fact that we have potential difference at the 6 ohm is IR. So we need to know what is the current there on 6 ohm. So that would be, remember. Alright, so from there we have 1.5 nano, so that would mean that we have 1.5 there, and then we have 1 ampere, and then that is supposed to be 0.5 ampere, and then what comes in must go out. So it's 1.5 ampere in, and that's 1.5 ampere out. So that's how it works. And that is, it has to be the same, the input and the output. And then the other thing that we also look at multiplying, 1.5 minus 1 is 0.5, multiplied by 6 gives us 3 volts. So our voltage, potential difference on 6 resistance is 3 volts. And then power is I times V, and we have V I times R, that is Ohm's law. So we're looking at the 6 ohm. So we have current, which is I is equals to V over R. And then from there we have power, which is power is supposed to be, it is change. It is wake over, so power is IR. Okay, let's substitute the I first. I is V over R, and then multiply by V, so it gives us V squared over R. And then power is work divided by time. So the rate of work is power, and then time there is 5 minutes. So that means we have 5 times 60. So it's changing 60, I mean minutes to seconds. That's our rate SI unit for time. And then work. All right, so we have work is equals to power times change in time, and then we have work net there, which is V squared over R, and then multiplied by. Now remember that we have, yeah, no, that's supposed to be R squared over. Okay, let's go back. Okay, so it's V squared over R multiplied by time, which is 5 times 60. So that gives us 3 squared over resistance is 6, and then multiplied by 5 times 60. So multiplying that 6 cancels, 6 into 650 gives us 10. So 10 times 9, I mean, it gives us 10 times 5 is 50. So 50 times 9 is 450, and that's 450 joule. I just want to thank everybody for watching. I really appreciate. If you have any questions and any comment, don't forget to leave it below. So that's the power dissipate on that